Algebra 2. We've already learned about exponents, and so now we're going to delve into radicals and how to simplify them, or just the fact that radicals are rad. So with that, I put this on here first as far as our perfect squares. If you're part of my class, I told you that this would happen. We need to really get accustomed to knowing our perfect squares, at least 1 through 12. Okay, so I put this on here just so that you can have a place, to add to your hard copy notes to help with the test for that. So looking at this, okay, radical 1, we know that that is square root of 1 is 1. Okay, square root of 4 is 2. Square root of 3 or 9 is 3. All right, and we're just going to go ahead and fill that in. Okay, and this is key for us because that's going to help us solve a lot of radicals. All right, I know that you have the STAR test today, so we're going to move rather quickly. Now, there's 3 different ways that you can break these down, or 3 different methods. There is the method that a lot of teachers teach, and the fact that teaching how to do perfect squares, pulling those out. There's also the factor tree, which probably maybe a lot of you have heard about, and then there's also one that that I don't know, upside down doghouse, and I'll teach you that one as well. Okay, that one's my personal favorite. So let's look at 320, radical 320. That's not a perfect square. There's no number that that goes into that. At least I don't know if there is, and hey, maybe it does, but we don't know that, right? So we look at this, okay, and we say, all right, is there a perfect square that I know goes into that? 32. Okay, I know that 16 goes into 32 twice. So 16 times 20 is 32. So remember, we know that, hey, just as we know that, all right, AB is the same as the square root of A times the square root of B. Okay, and I don't know why that is fuzzy about there. There you go. That's what we know. Okay, so then that also means that then if I have radical 6, I can break this down to equal radical 16 times radical 20. Well, what is radical 16? We found up top that that's a 4. So now I've got 4 radical 20. So now I can ask myself, okay, 20. Is there a perfect square up here, 1, 4, 9, 16? Do any of those go into 20 evenly? And yes, the radical 4 does. Okay, so we know then this is 4 times 5. Well, what is radical 4? Radical 4 is 2. We're going to bring a 2 out. All right, so I'm going to have 4 times 2 radical 5. Now when we bring those out, okay, we're going to multiply them together. So I've got 4 times 2, so I'm going to have 8 radical 5 as my answer. Okay, sorry, it's late. I don't know why my dog's barking so much. All right, let's look at number 3. 147. Okay, I'm going to show you now the factor tree method. All right, which is, we use this a lot, and basically, guys, you're just pulling out any numbers that go into 147. All right, well, I know a 7 can go into that. And let's see, 7 goes into 14 2 times. It goes into 7 once, so 21. And then I know the factors of 21 outside of 1 and 21 are 7's prime, if I don't do anything to it. This is 3 and 7. Okay. Now, key here, guys, is when I break something down, I like to cross them out, and then I like to circle my prime numbers. Remember, prime numbers are any number that only one in itself can go into it. So I have 2 7s and a 3. If you get a pair, they come outside the radical. So we see here I've got a pair of 7s. So I'm going to have 7 radical, then my leftover, which is 3. Okay? Now, here we go. 216. All right, now I know that I'm going to show the upside down doghouse method. All right, kind of like, looks a lot like synthetic division with that box. What we're going to do is we're going to put 216, and you're going to actually do upside down long division. Okay, I know this is an even number, so I do know that a 2 goes into it. Now, the key to this, people, is please, please, please pull out prime numbers. That's the only way this works. Okay, we pull out prime numbers, so we know it's a 2. And so I have this. That's going to be 108. Pull out another 2. I get 54. Still even number. I'm going to take a 2 out. And then, oh golly, you get 27. 27 divided by 3 is 9. And then 9 is 3 and 3. Okay, so notice how I'm just pulling a 2 out every time, then I pull a 3 out. Those are the easiest ones to always figure out. All right, from here, guys, circle your pairs. If I got a pair, they come out. So I'm going to have a 2 that comes out and a 3 that comes out. And I'm going to have a leftover 2 and a leftover 3. So the pairs come out, leftovers stay in. I'm sorry that that's fuzzy. I apologize in advance. Okay, maybe let's back it up just a little bit, see if that helps. Okay. Oh, my noses. Hey, there we go. All right, so then what I'm going to have is 2 times 3 is 6. 2 times 3 is 6. So 6 radical 6. That is my final answer. Let's try that again with 128. I like this method. I'm going to keep using this method. It's even, so I know a 2 goes into it. Let's see, 2 goes into it 64 times. And hey, it is okay to have to use a calculator on these. I understand these could be difficult. If you need it, use it. There's no shame in using it, especially if you get the right answer. 2, 32, 2, 16, 2, 8, 2, 4, 2, 2. So does everybody kind of see what I'm doing? So your prime numbers kind of line up on the left, and you just keep doing what you're doing. We got lucky. These were all even numbers, so I just kept going pop, 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 all the way down. So I got a pair of 2s, pair of 2s, pair of 2s. So what you have is 2 times 2 times 2, radical 2. 2 times 2 is 4, times 2 is 8. 8 radical 2 is my answer. Okay, so that's simplifying radicals in a whole. Now we're going to use operations. Okay, operations. So let's multiply, shall we? All right, when we multiply, guys, we're going to multiply insides times insides, outsides times outsides. So -2 times -5 is going to give me a positive 10. Okay, and then radical 5 and radical 5 is going to give me a radical 25. Uh-oh, 25. It's perfect radical. We know that that's going to be radical 5. Okay, or I mean, I'm sorry. We know that the radical 25 is 5. So what I got now is 10 times 5, which is 50. Okay? Here's another one. Outsides times outsides, inside times inside. So 2 times 5 will give me radical 10. 4 times 2 gives me an 8. 10 can't break down. That's my answer. Okay? Now, let's take it times here. Let's multiply in. All right? So I'm going to take this and just use distributive property to each one. Okay, now again, when I multiply, remember it's insides times insides, outsides times outsides. So if I have a radical 10 times negative 3 radical 2, you're going to get, there's no other outside here, so we know it's going to be a negative 3. 10 times 2, which is 20. Plus, now there is no radical here, guys, so I do have to take just, it's just going to be 4 radical 10. Okay? Now, 20 can break down, ladies and gentlemen. All right? If I go over here to the side, we know that what goes into 20, 2 and 10, 2 and 5. I have a pair. Okay. Oh, sorry, you can't see that really. So now I know that this 2 comes out, so it's really going to be negative 3 times 2, and my leftover is 5, plus 4 radical 10. Well, negative 3 times 2 is a negative 6 radical 5, plus 4 radical 10. Now, guys, I cannot add these because they are not like terms. Now, if this was a like radicals, absolutely, we can add them, but they are not like radicals, so therefore I cannot add them together. So negative 6 radical 5 plus 4 radical 10 is my answer. Okay. Last one of the notes, we have a binomial times a binomial here. Okay, this one's a lot of fun. Guess what we're going to have to use? FOIL. I'm going to do my first. Negative 3 times negative 5. That's going to give me a positive 15. I'm going to take negative 3 times a radical 2, which is going to give me a negative 3 radical 2. Outsides times outsides, insides times insides. I do my insides, and I'm going to get a negative 5 radical 2. And I'm going to do my last. And guys, we know that a radical 2 times radical 2 is just positive 2. So remember, if I take a radical and I take it times itself, it's going to give me that answer, right? Because remember, it's what times itself gives you that. So you would end up getting radical 4, which gives you 2 anyway. So we just say, hey, radical 2 times radical 2, you drop the radical, and it's a 2. Okay. Like terms. 15 and 2 give me 17. Okay, and see now, guys, since I have the same radical, I can take negative 3 minus 5. So you kind of add the coefficients. So I've got negative 3 minus 5, which gives me a negative 8 radical 2. Okay, hey, everybody, that's simplifying radicals in a nutshell. So I hope you enjoyed the lesson. Why don't you head on over and attempt the classwork and let me know if you have any questions. Have a great day.